This is 3.3, writing equations of polynomial functions. So your essential question that you're going to answer at the end, how do you write equations for polynomial functions? Polynomials have three different names that are important in order to describe the function and graph properly. So based on the degree, we call them different names. I've been using a lot of these names. We've been using a lot of these names, but now we're going to go through them. So degree of 0, meaning no variable at all. We call that a constant, right? It's just a number, no x's. Degree of 1, meaning the x is just the first power. We call that linear. Degree of 2, x squared, that's a quadratic. Degree of 3, x cubed, that's a cubic. Degree of 4, x to the 4th power, that's quartic. And then degree of 5, x to the 5th power is called quintic. Okay, so you want to start being able to recognize these names. Hopefully constant, linear, and quadratic are familiar, maybe even cubic. So you should be adding 3 to 2 words to your vocabulary: cubic, quartic, quintic. But you need to know all 6 of these words. Number 1, it says write an equation. Okay, so there's going to be write an equation, and then sometimes it'll write the equation. The equation means you have specific values. You got to use those specific values to answer the question. Write an equation means we're just going to have the x-intercepts, and that's it. So we're going to kind of match what we know, but we're not going to have all the information, basically. So as long as you match all the information we have, you're good. So write an equation. That's an important piece. We're not going to know all of the information. So we have how many zeros? 1, 2, 3, 4, 5. Remember, zeros are our x-intercepts. Okay, so I have 5 zeros, and they are all pass through. I'll say cross. They cross the x-axis, right? We're not bouncing, we're not touching. Okay, we're crossing through it. So that means they have to be single multiplicities. Single multiplicities, multiplicity of 1. Or I guess technically it's odds, but we're going to just assume 1 because that makes life a lot easier. So that means we're going to use a 5th degree polynomial, which is called a quintic. We just learned that now. But I mean, that's not that important. My end behavior is up, down. So we use our little chart. You're going to constantly use that. Always have that next to you. Draw it on the top if you need it. So that means the a value must be negative. It's an odd degree, 5. It has to be a degree of 5. So it's an odd degree, which is true. But up, down is a negative lead coefficient. So I want to write an equation. So it's y equals, and then I need a negative lead coefficient. So I'm going to write negative 2. Doesn't really matter. Any negative number will do. But now we have to write specifically for these problems, these zeros, okay? So I have a 0 of x, or negative 8, negative 4, positive 3, positive 5, and positive 7. So we got to think about how we get to these. So remember, we set the factors equal to 0. To get these intercepts, if we are actually using our equation, we would factor it all out, and we set each piece equal to 0. So we have to think, well, what equal to 0 would give me an x value of negative 8? Well, x plus 8, right? X plus 8, I subtract 8 from both sides, and I get x equals negative 8. That is the factor that lines up. So when I write my equation, I would write in parentheses x plus 8. That's one of my factors. The next one is negative 4. That's x plus 4, right? If I set that equal to 0, subtract 4 to both sides, I get x equals a negative 4. And then it's a positive now, so it just changes the sign. X minus 3, right? X minus 3 equals 0, so I'd add 3 to both sides, and I get x equals 3, and so on. And there are no exponents because we want a multiplicity of 1. And there we have it. In factored form, we don't have to multiply it out. We don't need to. It doesn't tell us to write it in standard form, so I'm just going to leave it in factored form. Got it. That is the equation, an equation that would match about that graph. Okay, so next one, an equation again. So I know I can actually see the y-intercept. We're just going to kind of ignore that. Just act like we can't. And so I have 1, 2, 3, 4, and they're all cross again. They all cross. So my x-intercepts I can write them out. -2, 0, -1, 0, +1, 0, and +2, 0. My end behavior is up, up. So I'm thinking it has to be even. I have 1, 2, 3, 4, all multiplicity of 1, 4. Good. So it is even. And we also need the lead coefficient, which I'm going to write lead coefficient out. Forgot to add this, so make sure you do. And that is, since it's up, up, that means it's a positive lead coefficient. Okay, so we write an equation. It has to be a positive lead coefficient, so I'm going to write a positive number. 3, doesn't matter. Okay, and now I need the factors that will create these intercepts. So x plus 2, if I set that equal to 0, I'd get -2. X plus 1, x minus 1, x minus 2. Done. That is an equation. That one's easy. Okay. Example 3 gets much more complicated because now we have the equation. Okay. So we use our intercepts still. So I have 1, 2 intercepts. But this is important. -1, 0 is an intercept, but this is a multiplicity of 2. I'm bouncing, I'm touching right there. I'm not passing through. So that's going to come into play. And then the other one is 2, 0. My end behavior, so down, or sorry, up, down. So that's an odd, and once again, lead coefficient. We need that. Since it's up, down, that is odd and negative. So I should match those. But now I don't just get to put anything I want. Now I need the equation. It has to be the equation for this specific graph. If I type this equation into Desmos, it better look exactly like this. Okay, so I need an extra point. That is not an x-intercept. So we can pick either of these points. I'm going to pick this one because it's a little easier to work with because it has a 0. And it's the y-intercept 0, 2. Notice it's counting by 2's there. Okay, so we actually have to work out some stuff here to get the a value. So instead of just writing a negative number, I know the a value should be negative, but I'm going to write a because I'm going to have to actually solve for this. Times, now we deal with this. So this is a -1, so x plus 1, but it's squared because I'm bouncing. Be careful about that. And this one is a 2, so x minus 2. That one's a positive, or a 1 for the exponent. And now I plug in my extra point. So 2 equals a 0 plus 1 squared, 0 minus 2. So we simplify. So I get 1 squared times -2. 1 squared is 1 times -2 is -2. So I get 2 equals -2a. Divide everything by -2. And I get -1 equals a. So that happens to be a -1. So my actually answer is -1 x plus 1 squared x minus 2. If you don't want to write the actual 1, you can write just the negative in front. That's the same thing. So that is the equation for the graph. So pay attention. Example 4, write the equation. So once again, we got to get the full picture here. So I have 3 intercepts, right? We just look, where does it cross or touch the x-axis? So -3, 0, but that one's a multiplicity of 2 because I'm touching or bouncing. -1, 0. It's kind of cut off, but that is negative. And +1, 0. My end behavior is down, down. So it's even and negative. Once again, forgot that. But remember, that's just a check. So it should be an even degree, negative lead coefficient, but we actually have to find it now. So I'm going to use the y-intercept. You don't have to use the y-intercept. You can use any extra point, which we'll see on the next problem. But so in this case, I have 0, 9. It's the y-intercept. Y value of 9, x value of 0. So we have to plug in. So I'm going to write kind of small here because I'm running out of space. So x plus 3 squared, because that one is bouncing. X plus 1, x minus 1. So I plug in, I get 9 equals a times 0 plus 3 squared, 0 plus 1, 0 minus 1, so it's a times 3 squared times 1 times negative 1. So 3 squared is 9 times 1 times negative 1 is negative 9. So 9 equals negative 9a. Divide, and I get negative 1 again. It will not always be negative 1. It's coincidence. So negative 1, x plus 3 squared, x plus 1, x minus 1. Done. Okay, so that's the equation. Example 5, it's a little different. It says write the equation and sketch the graph of the quartic. So I know it's going to be 4 things, degree 4, because that's quartic. Of f, where f of negative 6, negative 1, 3, and 4. So that's actually giving us our x-intercepts right here. If they equal 0, that's going to be an x-intercept. So negative 6, negative 1, positive 3, and positive 4. Those are my x-intercepts. And we have the point 2, comma, 144. 2, 144. Way the heck up there. So quartic is even. So we got to think that's either up, up, or down, down. It's 4 things. They never talk about multiplicity, so we're thinking it's only once. So if I started here, I'm actually going to draw it. If I started here, could I, using these x-intercepts, go to every point? We got a problem. If I started down, and I went, I'd have to add an extra x-intercept. We cannot. We have been told these are the x-intercepts. It is the only spot I can cross the x-axis. So right here, I know it's not going to work, because if I cross, and then I cross, I can't hit that point. So, cross, cross. Here we go. Now I can hit the point and cross only at those points that we have. Our x-intercepts are only time. I cannot cross again. A lot of people make that mistake, so make sure you're focused there. So there we have it. We have the sketch done. Now we need to write the equation. So y equals a x plus 6, x plus 1, x minus 3, x minus 4. That will give me my x-intercepts. I need to find a, so I'm going to plug in 2 for x, 144 for y. And notice it's a little more difficult because it's not a 0 we're working with. So we actually have to do some math inside those parentheses. So it's 8 times 3 times negative 1 times negative 2. So you might have to do some math on your calculator. A negative times a negative makes a positive, so this is going to make positive. 8 times 3 is 24, times 1 is 24, times 2 is 48. 144 equals 48a, so we actually have to divide. And I get 3. 144 divided by 48, if you didn't know, is 3. A equals 3. So I can also write my equation. Y equals 3, x plus 6, x plus 1, x minus 3, and x minus 4. Done. Example 6. Okay, sketch a graph and write an equation of a polynomial that has the following characteristics. It crosses, so that's multiplicity of 1, at negative 3 and 5. It touches, so remember that's multiplicity of 2. It's going to touch or bounce at 0 and 1. And is above the x-axis between 1 and 5. So between my x values of 1 and 5, I have to be above the x-axis. So I'm just going to put a point when I get to there above. It doesn't really matter. It doesn't say where exactly, but it needs to be above. Okay, and notice it's an equation. I should have been actually highlighting these. Oh, I haven't. An equation. It's not underlined, but they're telling us, they're not giving us all the information. Okay, so I got to sketch it first. Then I'll write an equation. So negative 3, positive 5, going to cross. At 0 and 1, I'm going to touch. Okay. So I'm going to, oh, sorry, last thing, between 1 and 5, so 1 and 5, these are between these two x-intercepts, I need to be above the x-axis, so I'm just going to put a point there. Okay, so we got to think, what is my degree? So I'm crossing, touching, touching, crossing. So 1, 2, 3, 4, 5, 6. I have 6 degrees. Okay, so it's going to be even, and we can kind of think about that. So I need to hit that spot. So I'm going to kind of trace it out. So if I start it up, I go, whoop, touch, touch. Oh, that's a problem, right? I can't cross again because I have to bounce on these guys, so I can't cross right there, and so I'm going to be in the wrong spot. So I'm thinking I'm going to start low. So touch, touch, get to that point, and then cross again. Do not cross the x-axis any extra times. Be careful of that. And make sure this is curved. We are not making points. We're not making sharp turns. We're not making right angle turns. It's curving in and out, like little parabolas all connected together. Okay. So y equals a x plus 3 x minus 5. Those are my two touches or crosses. Sorry, those are my two crosses. Now I have to do my two touches. X minus 0 squared, x minus 1 squared. There we go. Okay. And all I have to do is now have an a value that matches. It's an equation, so it's not going to be specific. I don't plug anything in. I'm looking down, down. It's negative, so I'm going to use any negative number I want. Negative 2. I can actually simplify this one. X minus 0 is just x, so when I write it out, it is going to be just an x squared. If you leave it as x minus 0 squared, I would give you full points. But notice that x minus 0 is just x, so I can rewrite x minus 0 squared as x squared. Okay. And we get to the last one. Sketch and write the equation. Once again, notice those things, read carefully. Of a quartic function, so that's a 4th degree, whose graph passes through, so that's multiplicity of 1, that point, and is tangent, that is a multiplicity of 2, at these 2 points. Okay. So a lot of people get thrown off. Passes through, so I have 1, 2, 3, 4, 5. Wait, that's a 5th degree. Pay attention. A lot of people just read it and don't really pay attention. An x-intercept has 0 for y. This first point, that's a 0 for x. This is my y-intercept. This is my extra point. It asked for the equation, remember? So they had to give us that extra point. There it is, right there. 0, negative 3. That's my extra point. So when I make this graph, I have a negative 1 and a positive 2 that I am going to tangent, going to bounce, going to touch those. I'm not going to cross the x-axis at all. Okay? And 0, negative 3. 1, 2, 3. Right there. I have to pass that point. So I know I'm going to start low, bounce, bounce, done. Okay? There's my sketch. So, write my equation. Y equals a. Remember, these factors are only the x-intercepts. We are not writing a factor for this one. I'm actually going to erase the underline because we do not want to write a factor of that. That's our extra point that we plug in to get our a. The only things that matter are the x-intercepts. So x plus 1 squared and x minus 2 squared because we're bouncing at both. And then I plug in negative 3 for y, 0 for x. Pay attention. Details are very, very important. A lot of details in this unit. 1 squared is 1. Negative 2 squared, negative times a negative makes a positive, so it's positive 4. Divide, and I get negative 3/4 equals a. It doesn't simplify this time. That's going to happen. Not always going to have nice, easy numbers to deal with. We'll have fractions a lot. And I have my answer. Okay, so you got to pay attention to those details. They're very important. All right, so using your essential question, write your 3-sentence summary.